Let's have another example, problem number 2. A researcher believed that 50% of rat population is female. He set up a traps to collect a number of rats in different parts of the Philippines. Out of 150 rats he collected, 74 are female. Would this support his claim? Use an alpha level equal to 0.05.
First step is to identify the null and alternative hypotheses.
We have the researcher's claim, so that can be our basis in constructing the null and alternative hypotheses. So for the first statement, we have the numerical values as 50%, so that will be the population proportion, and our null hypothesis will be equal to population proportion is equal to 0.50. And for the alternative hypothesis, we have the population proportion is not equal to 0.50 since we don't have any term synonymous to greater than or less than for the rest of the problems or for the entire problem itself.
Second step, we identify the alpha level and the tail test.
Level is directly stated as 0.05, so all you have to do is copy. And then to identify the number of tail tests, you go back to the alternative hypothesis and check the mathematical symbol that we used. So we used an equal symbol or not equal symbol. So since we used the not equal symbol, the number of tail tests is 2.
Step 3, identify the statistical test that you're going to use for this given word problem.
And since the values given in this problem is in proportion, then automatically this problem is under z-test for proportion. So just like the previous problem, we have the statement na out of 150 rats he collected, 74 are female. So from that given statement, we can parang say that this statement is a proportionality statement. That's why this problem is under z-test for proportion.
Step 4 is the computation.
We must identify the given values first before we can solve. We'll start with the population proportion, and that is x over n, and we will base it on the given proportionality statement. So we have out of 150 rats he collected, 74 are female. So we have the x as 74 and n for the total number of samples as 150. Next is to rewrite the fraction form into its decimal form so that we can solve easily. So 74 divided by 150 is equal to 0.49. Again, kindly round off to the nearest second decimal number. Next is the population proportion, and that is equivalent to 0.50. Next is the value for the Q with the formula 1 minus P. Substituting, we will have 1 minus 0.50 since our value for P is 0.50 or 0.5. Simplifying, the value for Q is 0.5 or 0.50. Now that the values are complete, we can now substitute in the given formula for z-test of proportion. Substituting, we'll have 0.49 minus 0.50 all over the square root of 0.50 times 0.50 all over 150. For 4-liner calculator, press fraction and then 0.49 minus 0.5 all over the square root of the fraction 0.5 or 0.50 times 0.5 or 0.50 all over 150, and then equal sign. Then you have to press S to D or yung F to D to change this fraction form to decimal. Then that will be the answer. For 2-liner calculator, this will be the display in your calculator. First, open parentheses, then 0.49 minus 0.5, close parentheses, and then fraction, and then open parentheses, then square root, then another open parentheses, 0.5 times 0.5 or 0.50 times 0.50, close parentheses, fraction symbol, and then 150, and then 2 close parentheses, and then equal sign. This will be the answer.
The final answer for z computed is negative 0.24. Step 5 is the decision rule. Reject null hypothesis if the absolute value of z computed is greater than or equal to z tabular. We already know the z computed. Next is to get the value for the z tabular. And for us to get the values for the z tabular, we have to go back to our step 2 to identify the alpha level or level of significance and the number of tailed tests. Going back to step 2, we have alpha level as 0.05 and two-tailed test. Meaning to say po, we have to draw an imaginary vertical line passing through 0.05. And we also have to draw an imaginary horizontal line passing through two-tailed test. And the intersection of the horizontal and the vertical line is the value for our z tabular. Substituting the values for z computed and z tabular, we will have the decision rule as reject null hypothesis if the absolute value of negative 0.24 is greater than or equal to the absolute value of 1.96. Step 6, identify if we have to reject the null hypothesis or we fail to reject the null hypothesis. We go back to the mathematical statement and check if it is true or false. So, the absolute value daw po of negative 0.24 is greater than or equal to 1.96. We extract the absolute value, so we will have 0.24 is greater than or equal to 1.96, which is false. That's why we failed to reject the null hypothesis. Next step and last step for this given problem is the conclusion. Since we failed to reject the null hypothesis, our basis for the conclusion will be the null hypothesis, which means that proportion or population proportion is equal to 50%, or in statement form, we can say that 50% of rat population is female.